slab out of a unit cell. Here we have a unit cell. This is the unit cell of tin oxide, and we are going to build a slab with 110 plane exposed. Here we can see different planes exposed. To know the planes that are exposed on the surface, we can go here, lattice planes, and here we can have new. We have this 110 plane, 100 plane exposed, as we can see here. Also, the other plane that is exposed is 010. Here we can see, and 001 plane is exposed. The plane that we need on the surface is 110, and we are going to build a slab out of it. So this is, here we can see this, we can shift it by 1. So this would be the exposed plane. So we are to build this, we will increase the boundaries first. We'll have a boundary of 4. We'll increase it to 4. Okay. Here we can see our plane. We'll shift this plane a bit up. Okay. Here we can see this. We can have one more with ether at 5. So here we can see both the planes. Now in this particular structure, we are going to have the periodicity. We will have these planes perpendicular. Now we have this. Then we have to search for the periodicity. If we zoom in and see for the periodicity, what we see is the atoms that we have here. This is having periodicity here, this is having here, and this is having here. By leaving one particular atom, we can see the periodicity. So we'll consider 4 atoms. In this way we can have a better vision. This is having periodicity here, and as well as this is having here. So we'll consider this 4 atoms and have a cube out of it, and we'll delete all the other atoms present. So we'll zoom out, select the atoms to the left, delete them by leaving one here. We'll select all the atoms to the right. Also atoms to the row, and also the atoms at the bottom. So here we have this particular atom is having a periodicity here, 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 as well as this is having here and also here. So the atoms to the left of this should be deleted. So this is having here, and we will delete all the atoms to the left. So these oxygen atoms are not required. Okay, so this is our unit cell. We have to build a unit cell out of it. But here we have our 110 plane exposed. Now, in this particular structure, we will consider this atom to be origin, this to be A direction, this to be B direction, and the atom above here having periodicity to be at the C direction or C coordinate. So for this, we'll select this particular atom. Here we should be able to see the coordinates. Here we can see the coordinates, that is 1, 2, 4. This is our origin. We'll use an Excel file for this, having here origin A, B, C, and the modified ABC. So coordinates for origin are 1, 2, 4. Have them 1, 2, 4, the matrix. And now for A direction we have here that is 2, 1, 4, 2, 1, 2, 1, 4. For B it is 1, 2, 2, 1, 2, 2. For C we have this, that is 2, 3, 4, 2, 3, 4. Now we will subtract these values from the origin. So 2 minus 1 would be 1, 1 minus 2 would be minus 1, 4 minus 4 would be 0. Similarly, 1 minus 1 would be 0, 2 minus 2 would be 0, and 2 minus 4 would be minus 2. Third, 2 minus 1 would be 1, 3 minus 2 would be 1, and 4 minus 4 would be 0. We use this matrix in transforming the unit cell that we have. So for this, we once again import our unit cell and now go to edit data, unit cell, transform. Here we will insert the matrix that we have just calculated, that is 1 minus 1 0, 1 minus 1 0, 0 0 minus 2, 0 0 minus 2, and the third one is 1 1 0, 1 1 0. Okay, yes, okay, apply, okay. So here we have our unit cell with 1 1 0 plane exposed, atoms with 110 plane exposed. So thank you for watching this video. Also subscribe to watch more such content. Thank you.